In section 9.2, we are still working with rational expressions. Remember, rational expressions, we're going to see some variables in the denominator. And with these rational expressions, we're just trying to simplify these. So the first two questions, we're going to be just reducing through factoring and canceling like terms. And then in the next two problems, we're going to be multiplying. And then the last two, we're going to divide. So all fall under the category of simplifying these rational expressions. Now, again, when we say simplify, we don't mean to solve anything, right? We don't want x equals 2 or 5 or x equals 10, right? That's not what we're looking for. We're just looking to factor, which you can clearly see as step 1. And then after we've factored, cancel, reduce, and then whatever you're left with, that's it. Don't feel like you have to, push the problem or go too far and try to get something that you're not really looking for, okay? So it doesn't have to be x equals a number for your final answer. Again, there's no equal sign, so you're just looking to factor and reduce. For question number 1, I look in the numerator. There is nothing I can reduce or factor here. So we're going to leave it as 2x to the third power. And then in the denominator, I'm looking and I'm asking myself, can I factor anything? And the answer is yes. They both have a 2x in common, so I'm going to factor out a 2x. That leaves me with 2x minus 3. And if I look at what I have now, in the numerator, we see that we have a 2x cubed. In the denominator, we have 2x times the quantity 2x minus 3. And so if I think about what I can cancel, remember what this actually is, all right? As you get more familiar with this, you're going to get more comfortable with it. But in the numerator, I have 2 times x times x times x. In the denominator, we have 2 times x times 2x minus 3, okay? You have to remember that this 2x here, because it is attached to this negative 3, we cannot do anything with this unless there was also a 2x minus 3 in the numerator. So if this was the case, then we could cancel these. But because we don't have something identical in the numerator, don't think you can just go ahead and cancel this 2x and that 2x. That is not how that works, right? The subtraction symbol here, or whether it's addition, is going to keep this group together unless you have something identical in the numerator that you can cancel out. However, we do see that we have these 2's and these x's that can cancel, and so we should get a final answer of x times x in the numerator, which is x squared. In the denominator, we have 2x minus 3. So that's going to be your final answer. Again, don't do anything else. Don't feel like you have to cancel these x's because you cannot. That's going to be your final answer. Question number 2, again, we are looking to factor. That's always your first step. So when I look in the numerator, I'm going to try the AC method. So I'm going to multiply these together. And so 6 times negative 3 is negative 18. And I'm looking for two numbers that multiply to be negative 18, but add up to be negative 7. That should be negative 9 and positive 2. All right, so again, from here, lots of ways to solve this. You could go ahead and do grouping. You could do the divide and slide method. My personal preference is to take 6x over negative 9, and then you're going to take ax, which again, a is 6, and divide that by 2. In this case, we can reduce both of these. The first one we can reduce by a factor of 3. So 6 divided by 3 is 2, and negative 9 divided by 3 is negative 3. In the second fraction, we can divide both by 2. So 6x divided by 2 is 3x, and 2 divided by 2 is 1. And so we should get this factorization of the numerator. You can go get you can distribute everything just to double check, but we should get the right answer there. And so my numerator is now 2x minus 3, and the denominator is the numerator is still 3x plus 1 for that other factor. In the denominator, we can factor out x squared, and if I take out an x squared, we're left with 2x minus 3. And at this point here, we can stop factoring because we factored the numerator, we factored the denominator, and I want to look for anything that can cancel. And because I have a 2x minus 3 on top and a 2x minus 3 on the bottom, we are done, giving us an answer of 3x plus 1 over x squared. And that's going to be your final answer. Here we have some multiplication, all right? With these problems, I'm going to kind of speed through the factoring because this is something that we should have mastered already in Chapter 5 with quadratics. So as I mentioned, this is coming back all year long, so you'll see it next year as well. If you don't feel like you're a master or an expert at this yet, you need to take the time to master it. So in the numerator for the first problem, we're going to factor out an x, leaving me with x minus 4. In that denominator, I'm going to take out an x, leaving me with x squared minus 9. In my second fraction, I'm looking for two numbers that multiply to be 15 and add up to be 8, and that's 5 and 3. And in the denominator, I'm looking for two numbers that multiply to be negative 8, but add up to be negative 2, and that's negative 4 and positive 2. All right, now I actually noticed that this denominator can be simplified a little bit further, right? This is a difference of squares. So this is actually, I'm going to erase this, x squared minus 9 is really x plus 3 times x minus 3. So that's going to go in this denominator here, x plus 3, x minus 3. And now everything is factored. I'm going to look for what cancels out, okay? Now, it could be within the same fraction, like these x's will cancel. They're in the same fraction. I could even look in the numerator of one fraction and the denominator of the other fraction, and those would also cancel. So this x minus 4 and this x minus 4 will cancel. This x plus 3 and that x plus 3 will cancel. And it looks like that's all I have. I don't think anything else is going to cancel here. So we're going to go ahead and write our final answer. In the numerator, we have x plus 5. In the denominator, we have x minus 3. We also have an x plus 2. All right. Now, I'm fine with this answer. This is simplified. You might also see when you're doing the SAT or ACT that they actually have the denominator FOILed. So if that's the case, you're going to leave the numerator the same. And if I FOIL the denominator, we would get x squared minus x minus 6. So you could see it either way. If you have either of these answers, I'm okay with those. I'm not too picky about that. So either of those would be okay. Question number 4. Notice I have no binomials here, right? There's nothing inside parentheses. And I don't have to factor anything because, there's no plus or minus signs. So I'm just looking to combine everything in my numerator, combine everything in my denominator, and then maybe use some exponent rules, okay? Again, we typically like to reduce first before I expand. So if there's any numbers that I feel like I can reduce first, I'm going to try to reduce those as quickly as possible. So if I look in the numerator and denominator at just my numbers, I'm going to put these in red here, 4, 6, 15, and 35. And so I'm going to try to reduce these numbers first. And when I look at them, I should notice that 15 over 35, if I divide both these by 5, we get 3 over 7. So those do reduce. And then if I look at the 3 that I have, the 3 and the 6, I notice that 3 over 6 also reduces, right? 3 over 6 is the same as 1 over 2. So if I look at my numbers in the numerator, 4 times 1 is 4. And if I look at what I have in the denominator, 2 times 7 is 14. All right? And if we look at that, we might say, well, wait a minute, I could have even simplified more, right? We could have taken 4 over 2 and changed it to 2 over 1. And so you can see that if you simplify everything at the beginning, it leaves less work at the end, right? We still have to simplify that 4 over 14. And so we really need to make sure that that is 2 over 7, right? 4 over 2 becomes 2 over 1. And now when you multiply, you can clearly see it's 2 over 7. Again, so I always like to do everything simplifying first. That way, again, it's just less work at the end of the problem. So if I multiply across with my variables here, we just have x squared in the numerator. Here I've got y to the 5th, but also a y to the 4th. And we know that y to the 5th times y to the 4th is y to the 9th. I also have the letter z in the numerator. If I look in my denominator, we've got x times x to the 4th. Well, that's a total of 5, so that's x to the 5th. I have one letter y, and I have z to the 6th. So I just want to make sure I'm simplifying all these variables appropriately. So we're still going to have the 2 over 7. And if I look at the x's, right, my rule is that I subtract the exponents. So x squared over x to the 5th. If I do 2 minus 5, we get a negative 3, which is just 1 over x cubed. So I know I'm going to have x cubed in the denominator. And then we can go ahead and we can worry about the letter y's. And if I look at the letter y's, we can see that we've got y to the 9th over y. So that means I've got y to the 9th over y. If I subtract 9 minus 1, that's 8. And so that would give me y to the 8th in the numerator. So we've got y to the 8th up here. And then the last thing I want to go ahead and simplify the z's. And if I look at the letter z, we can see that we've got z over z to the 6th and z over z to the 6th. Remember, that's really z to the first power. 1 minus 6 is negative 5, which is really 1 over z to the positive 5th. So we should expect to see z to the 5th in the denominator. And so we're going to go ahead and write that down here. Now at this point here, we can see that my numbers are simplified. The y's, the x's, and the z's are also all simplified. So this is our final answer. Question number 5, we now have division. So this is almost identical to the previous one, you'll notice, right? Again, there's no plus or minus signs anywhere here. The first thing we have to do is remember that dividing by a fraction, right? Dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to first start by rewriting this as 5a cubed b to the 4th over 12ab to the 8th times 8a to the 6th over 15b to the 6th. Okay, so first step is just to, instead of dividing by a fraction, we're going to multiply by the reciprocal. So that's always going to be your first step. And now once you've done that first step, you should notice it's almost the same as the one we just did in question number 4. So if we go ahead and give this a shot, again, we're going to try to simplify as much as we can. So I'm going to look here. I see that 5 over 15 reduces to be 1/3. And we see here that 8 over 12, if I divide both of these by 4, we get 2 over 3. So if I think about what my numbers are going to be, in the numerator we have 1 times 2 is 2. In the denominator, 3 times 3 is 9. And 2/9 is simplified. I'm going to go ahead and look at my numerator now with the variables. A to the 3rd times a to the 6th is a to the 9th. And then we have a b to the 4th as well. In the denominator, we just have the letter a, and b to the 8th times b to the 6th is b to the 14th. So last thing I have to do here is simplify the letter a's and the letter b's. And if I look at the letter a's, we've got a to the 9th over a. We know that a to the 9th over a to the 1st, we can subtract these. So this is a to the 8th power. And if I look at my letter b, we know that b to the 4th over b to the 14th. If I subtract these, 4 minus 14 is negative 10. But again, I'm not allowed to have any negative exponents in my final answer. So that's 1 over b to the 10th. So if here I'm thinking about everything that's in my numerator versus denominator, in my numerator we have a 2. We also have a to the 8th. Right? Here's the 2 and here's the a to the 8th. If I think about what I have in my denominator, we have a 9 and we have a b to the 10th. Right? Here's the 9, here's b to the 10th. And that's going to be your final answer. You can't reduce the numbers or the variables any further. Last question here is again with division. So we know when we see division, we don't worry about anything else before we start to change the division to multiplication and then flip the second fraction. So this is going to be 3x squared plus 15x over 3x squared minus 8x plus 4. And we're going to keep it to multiplication, x to the 4th minus 16 over x squared plus 7x plus 10. All right, so again, that first fraction stays the exact same, but when I change division to multiplication, we do have to use the reciprocal of this fraction. At this point here, I need to factor. All right, so I'm going to quick do this factoring. Again, if you are not an expert at this, you need to get some practice in to make sure that you can do this almost automatically. For the numerator up here, I can divide out a 3x, so that's going to be a 3x. X plus 5 is what I have remaining. In the denominator, this is my AC method. This gives me 3x minus 2 and another x minus 2. If you're not sure how I got this, you can look back at, what question was it? I think it was question 2 here, right? This is the AC method. Over here on the right side fraction, we're going to reduce this to, well, this is a difference of squares. So this is really x squared minus 4 times x squared plus 4. right? We know that 4 times 4 is 16, and x squared times x squared is x to the 4th. In my denominator, we've got x plus 5 and x plus 2, all right? If you're not sure how I got any of this, it's all factoring from chapter 5, so you might have to go back and brush up on chapter 5. One last thing that I see that I can factor is this binomial right here. It turns out that when you use difference of squares on x squared minus 16, it ends up factoring into another difference of squares. So we know that this is really x plus 2 times x minus 2. So what I'm going to change this into, I'm just going to erase this real quick and change it. We're going to change that into x plus 2, x minus 2. X plus 2, x minus 2. All right. Now we can't factor this because there's a plus here. There's no such thing as a sum of squares when we factor. So we can't factor that at all, but everything else here looks factored. We're going to go ahead and start canceling off those common factors. So here we see an x plus 5 and another x plus 5. I see an x minus 2 and another x minus 2. Here I have an x plus 2 and another x plus 2. And it is tempting to maybe look at this and be like, oh, you know, the 3x and the 3x can cancel out, but that would be incorrect. Again, whenever you are given a binomial here, whether this is a plus or a minus, because of that addition or subtraction, these are stuck together. Unless you have another identical 3x minus 2, these are very different numbers, right? You can imagine plugging in some number for x, and those would be different numbers. You can't just cancel them out because they are different values, all right? You can't just cancel out part of one number. So in my numerator, if I look at what I have a 3x. I still have an x squared plus 4. In my denominator, all we have is a 3x minus 2. So this is a good answer. Again, on your, if you're doing the ACT or SAT, you might see the top expanded back. And so if we distribute that 3x, that would be 3x cubed plus 12x. The denominator would stay the same as 3x minus 2. And this also would be an acceptable answer, okay? So I would take either of those. The only reason to do this extra step would, again, be to try to match up your answer on the ACT or SAT, but I would take either of